Hi, I'm Benny D, and in this video we're going to look at integration by recognition. Okay, so this is something that comes up a lot on exams, but most of the textbooks I find don't actually do a very good job of explaining how this works. Okay, so what we have is a problem where we need to integrate g of x dx, okay, but we can't find it directly. We don't have the strategies or skills to do that. Okay, so what we do is we start with a different function, f of x, and differentiate it to get f dash of x. Okay, and f dash of x and g of x will be related but not the same. Okay, so there'll be a link between those two. And what we do is we set up the equation, the integral of f dash of x dx equaling f of x plus c, because we know that's true. If we take a function, differentiate it to get f dash of x, okay, and then integrate that derivative, we get back to our original function plus c. Okay, then what we want to do is modify this equation that we've got. Okay, modify this so that f dash of x dx is equal to g of x. Okay, so that might be that we're going to take out a factor or add a factor in or something like that. Okay, but when we've done that, we've actually got our answer, and all we need to do then is potentially sub in terminals as required, okay, to finish off our question. Okay, and we're going to see this in some worked examples in a moment. Okay, so you know that you need to use this process when a question asks you to differentiate a function and then hence integrate another function. That's the key term that you're looking for there, to know that you need to do this process. Okay, it's diff a function, then hence integrate another function. Okay, and you might be able to spot that they're related before you start. Let's have a look at a couple of worked examples here. Okay, so our first one is we're going to differentiate log to the base e of 5x squared take 2, and hence anti-differentiate or integrate x on 5x squared take 2 dx. Okay, this is something that we won't be able to do normally. So I'm going to say let f of x equal log to the base e of 5x squared take 2. So remember, when we differentiate a log function, the derivative of what's inside of our function, in this case 10x, goes on top over what was in there originally, which is 5x squared take 2. Okay, so if you're liking one of these questions, this would be the part A. Okay, differentiate this. Done. Okay, part B would say, hence do this. Okay, so what we're going to do is we're going to set up this equation where we integrate 10x on 5x squared take 2 dx. I'm going to set that equal to our original function, log to the base e of 5x squared take 2 plus c. Okay, so we can see that we're close. This is similar to this, okay, but we've got this 10 here. Okay, so this is, if you like, is 10 times bigger than what it needs to be. But we know from our laws of integration, we are allowed to bring this factor of 10 out the front. And so we've got 10 times the integral of x on 5x squared take 2 dx, and that's got us, this is still equaling this, okay, this is the equation that we're modifying. Right, now it's simply just a matter of dividing by 10 because we're almost there. So I'm going to divide everything by 10 to leave us with x on 5x squared take 2 dx, and so that we've got 1 on 10 log to the base e of 5x squared take 2 plus c. Now I don't have to divide my c by 10 because it's a constant. A constant divided by 10 is still just a constant. Okay, and you can see now we're actually finished. Okay, a lot of kids actually get here and go, oh, what do I do next? Well, you don't actually have to do anything. You're asked to integrate this. Okay, and we've done that. We've found that if we integrate this, we're going to get this. Okay, problem done. So let's move on to another worked example. Okay, so we want to differentiate e to the x cubed, and then hence find the integral from 0 to 1 of 6x squared e to the x cubed dx. Okay, so we'll start off again with f of x equaling e to the x cubed. Okay, therefore f dash of x equals, we take our derivative of our x cubed, which is 3x squared, and times it by e to the x cubed. Okay, so we've got our derivative. Okay, so now we're going to hence find this one. So this is where we set up this equation and say that we've got the integral. Right, now we're going from 0 to 1 in this case of 3x squared e to the x cubed dx, right, is going to equal e to the x cubed. Okay, we don't need the plus c now because we've got our terminals. Okay, but we don't have what we want. We need it to be 6, so we've got to multiply everything by 2. Okay, and say that we've got 0 to 1 of 6x squared e to the, x cubed dx equaling 2e to the x cubed. Okay. Now we've got our integral that we needed. Okay, we've got an answer, but now we need to do our terminals. Okay, so I'm going to move over here so I've got room. So we're saying that that's equal to our e to the x cubed from 0 to 1. Okay, so we're going to have 2e, because x being 1, okay, just 1 cubed is just 1, e to the 1 is just e, okay, minus, okay, anything to the power of 0 is just 1, okay, 1 times 2 is 2. Okay, so our answer is going to be 2e take 2, or if you like, 2 outside of e take 1. Okay, so I've got one more problem I want to show you, but I just need to rub this one out first. Okay, which is we want to differentiate x sine x, and we're going to then hence integrate x cos x. Okay, so you can see x cos x isn't something that we would normally be able to do. Okay, so that's why we're going to do this process. So in this case, oops, I'm going to say let h of x equal x sine x. So you can see here that we've actually got a product rule. Okay, so I'm going to say let f of x equal x. So that means I'm going to get f dash of x being 1. I'm going to get g of x being sine x. So g dash of x is going to be cos of x. Okay, so that means that h dash of x equals, all we're going to do is cross multiply. So we're going to get 1 times sine is sine of x plus x cos x. Okay, so I've got my derivative now. Excellent. Okay, so that's part A if you like. Now part B, we need to set up our integration here and say, well, we're integrating sine x plus x cos of x dx, and that's going to equal x sine x plus c. Okay, so you can see this one's a little bit different though. Okay, it's not this straight, just go multiply or divide or anything like that. Okay, I've got two parts here, and what I'm allowed to do, okay, is split this up into two parts. Okay, so you can see I've split into the integral of sine x dx plus the integral of x cos x dx. And this is what we want. So I've got to take this away. Okay, so I've got now x cos x dx equaling x sine x minus the integral of sine x dx plus the c. I've just left that c at the end because yes, we're going to get a constant from doing this as well, but we'll see what happens there. Okay, so our x cos x, which is what we need, equals x sine x. Antiderivative of sine is negative cos, so a negative take a negative is a positive, so we're going to get plus cos of x plus c. So what would happen, if you like, is we could call this one c1, 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 then we'd have c1 plus c2 as a constant from doing this integration. Well, you could say c1 plus c2 is c3, so it really doesn't make any difference. Okay, a constant plus a constant is just a bigger constant. It doesn't matter what it is, we can just leave it. We only need that one c. And again, we're actually done here, okay, because this is what we needed to find, okay, and we have now found it. Okay, so you see this one's a little bit different. okay, in that it wasn't just multiplying or dividing by a constant, that we actually need to do that extra work, split our integral into two parts. One of those parts was something that we could actually integrate. And this would probably be the hardest version of these type of questions that you're likely to see. So look, hopefully that's enough to get you through the questions on this section.